Hey guys, this is the third set of notes in the Pythagorean theorem. Today we're actually going to be exploring the Pythagorean relationship. But before we get started, we need to review a little bit of vocabulary. So what is a right triangle? So a right triangle is a triangle that has a 90-degree angle. And when we have a 90-degree angle, we actually represent it as a square. So that's a 90-degree angle. So when we have a right triangle, these actually have names. The sides have names. So wherever our 90-degree angle is, the sides on either side of that angle are called legs. And the side which is across, directly across from that 90-degree angle, is called the hypotenuse. And it is always the longest side. So each of these side lengths actually corresponds with squares. And I'm just going to bring up this picture here. Because you guys know how awful I am at drawing. So let's use this instead. Okay, so each of these sides corresponds with a square. So usually the hypotenuse, which is the side across from the 90-degree angle, we call C. And then the legs are called A and B. Well, we want to look at the area of the squares. So this square would be C squared, this would be A squared, and this would be B squared. Okay, let's put some numbers to these. So let's say that A is equal to 3, C is equal to 5, and B is equal to 4. Well, what are their areas then? C squared would be equal to 5 times 5, which is 25. B squared is 4 times 4, which is 16. And A squared is 3 times 3, which equals 9. Huh. I wonder if we can do anything with those. Well, we'll talk about that later. So again, we have our C, our A, and our B. So let's say this is 5, this is 13, and this is 12. Again, remember your C that's across from your 90-degree angle is always going to be the biggest side. So it's going to have the biggest number. So 5 squared is 25, 12 squared is 144, and 13 squared is 169. Kind of interesting. Can you guys spot a relationship yet? Really doesn't matter which side you label A and B, just the legs have to be it. So let's try 6, 8, and 10. So 8 squared is 64. 6 squared is 36. 10 squared is 100. So what we can actually do if you look at these is that these side lengths are related to each other. And how we do that is if we look at the areas, and we look at the areas of our squares. What is 9 plus 16? Oh, it's 25. Well, maybe that's a coincidence. Let's try another one. What is 25 plus 144? Well, that's 169. Oh, okay. Two of them. Let's see if the third one works. So now we have 36 plus 64, which is equal to, it is 100. That is actually what the Pythagorean relationship is that a squared plus b squared is equal to c squared. So the area of the square for each of the legs added together gives you the area of the longest side. So once we know that, we can actually use that to identify if something is a right triangle or not. But before we move on, let's do one more example. Okay, so let's identify a right triangle. Okay, so we say that a triangle has the side lengths of 5 centimeters, 7 centimeters, and 9 centimeters. What are the areas of the 3 squares that can be drawn on the side of the triangle? So the very first thing we have to do is draw a triangle. This triangle is not going to be to scale. And then I'm going to draw my squares. So remember, the longest side is always where? It's across from the 90-degree angle. So this one will be our 9 centimeters. And it doesn't really matter which is which, because these are one smaller than the other. I'm just going to put it to the corresponding sides. But again, this isn't to scale. So now we have to look at what the area is. So 5 times 5 gives us 25 centimeters squared. 9 times 9 gives us 81 centimeters squared. 7 times 7 gives us 49 centimeters squared. So is this a right triangle? Well, what we have to do is add these together and see if we get it. So we take the two legs, 25 centimeters squared plus 49 centimeters squared, and we add them together. So that gives us 474. Is that equal to 81? No. So no, this is not a right triangle. Which means this square shouldn't be there. It should have been a question mark. Okay, let's try one more. So a triangle has the side lengths of 12, 16, and 20. Let's see if it's a right triangle. Well, the first thing we do is we draw a triangle. But again, because we don't know if this is a right triangle or not, instead of putting the square, I really should be putting a question mark, because that's what we're trying to find out. Now I put my squares. Again, this isn't to scale. And I label my sides. So the longest side would be the one across from the right angle, which is the 90-degree angle. So this one would be the 20 centimeters. Now I find the area. So 20 times 20 is 400 centimeters squared. 12 times 12 is our 144 centimeters squared. And that leaves us with our 16 times 16, which gives us 256 centimeters squared. Okay, so to determine whether it is a right triangle or not, what we should be doing is adding them together. So I take the two legs, and it's 144 centimeters squared plus 256 centimeters squared. And if I add those two together, 4 plus 6 gives me 0. 1 plus 4 is 5, plus 5, 0. 1 plus 1 is 2, plus 2. Ooh, 400 centimeters squared. So this one is a right triangle. So do remember, when you're doing these questions, not only can you add, but you can also subtract to find out what one of the legs is. If we were trying to figure out what the area of this one was, we could do 400 minus 144, and that would give us 256. So there's a bunch of different ways for us to use this equation to find out answers to questions. So your assignment today is going to be on page 17, and it's going to be questions 2, 6, 9, 10, 17, and 19. Okay, well, I hope this made sense. If it didn't, again, send me a message on Remind or email me. Hope you guys have a great day. Bye.